All right, so this on your separate paper will be assignment number 32. So basically just kind of, do your normal thing, put your name up in the corner and the date and the period and all that stuff, up here. And then this is assignment number 32. All right, we're back. So on every one of these, the reason I don't want you to do it on here is because A, there's not enough room, and B, we're going to use this for something else probably tomorrow. So I want to use these graphs again. So just keep this paper intact. Just put your name on it. Don't fold it up or anything. Just don't lose it. And then we'll use this again tomorrow, but again for something similar but different. Got it? All right. So just like we learned yesterday, we're going to be doing intervals of increase and decrease. These ones are going to be a little bit, maybe not trickier. There's just a little bit more meat on the bone. So problem one, take a look down at your paper. How many intervals do you see? Count carefully. I see 5. I see that the graph goes up, then down, then up, then down, and then up. So good counting. That was indeed 5 intervals. So to be organized about this, so this is problem one. So I like to do all of the increasing intervals first. You don't have to do it this way. I just think it's a little bit more tidy to go through and name all of the increasing intervals first. So we're going to start with increasing. And I'm only going to do, I don't know, maybe a couple with you, and then the rest are yours. So increasing over, remember, that's the way we phrase this. We say it's increasing over the following intervals. And so what's the first interval of increase that you see? So if you're coming in, from left to right, and you're swooping across from left to right, where does the graph even come into existence? -5. Can we agree? So when I'm on the x-axis and I'm traveling in from left to right, the graph begins its existence at -5. And because -5 is included and it starts the growth process, we're going to want to do a square bracket at -5. And when does that interval of increase stop? At -3. Good. And remember that since it's at the peak of a mountain, we want a round bracket at -3. And then we're just going to put a comma. So that's one down, and I see 2 more intervals of increase. One of them is a little bit more substantial perhaps than the other, but as we work our way across now, if you're on that roller coaster, yeah, it turns and goes downhill for a while. We'll come back to that. Where does the next interval of increase begin? At 1. Good. And remember, that's the bottom of a valley. So again, we're going to use a round interval notation there. And when does it stop increasing? At 3. Good. And again, that's the top of a peak, so we'll round it off. And then it dips a little bit, and then it has one more little baby interval of increase. And where is that? It goes from 4 to 5. Very good. So from 4 on the x-axis to 5 on the x-axis, you can see there's a little period of growth on the function there. So that one is also going to be open, 4 to 5. Yeah, so we're going to use a round on the 5 this time. Unlike the left side when we started with a square, because that point was included, this one is excluded, so we want to exclude it with a round bracket, a round parenthesis like that. Okay, and now we're going to list all of the intervals of decrease. So we're going to say decreasing over. How many intervals of decrease do you see? I see 2. Yeah, the roller coaster dips twice. So the first dip occurs from what x's? From where to where? -3 to 1. Very good. And they're both exclusive because they're the top of a mountain and the base of a valley. So we're going to go open, or exclusive, exclusive from, like you said, -3. It starts to go down and it stops going down at +1. And then we have one more interval of decrease. And where does it go? It's a very short one. From where to where? 3 to 4. Very good. And that is what you're doing for each of these 12 problems. Some problems are going to take longer than others. Which one obviously is going to take longer than all the others? Problem 6. Problem 6 has 1, 2, 3, 4, 5, 6 different intervals. And so there's a little bit more meat on that bone. But then you look at something, I'll do one more with you here. Let's do problem 2. All right. How many intervals do you see total on problem 2? Yeah, just 2. I see an increase and then a decrease. This one's pretty unexciting. However, you do notice that this one has an arrow on it, so we know that the concept of infinity is going to come into play. It's not going to come into play on the first interval because the first interval is finite. It starts at an x and then it ends at an x. So this one isn't going to have any infinities in it. Where does the first? Oh, we have to write this down. Increasing. And please don't abbreviate and stuff. Just write the words out. It takes like 2 seconds. So increasing over. What's our interval of increase? Yeah, from -6 on the x-axis to -4 on the x-axis, we agree that the graph is growing. And because of the open circle on the left, we want to use a round parenthesis for the beginning, right? The graph does not exist at -6. So -6 until we get to -4. And as you're used to by now, because it's the top, the peak of a mountain, and we want to, again, round this one off, right? Remember, at the top of a mountain or at the base of a valley, the graph is neither increasing nor decreasing, so we want to exclude that point from our intervals. So from -6 to -4, it's increasing. And that, again, is the only interval of increase for this particular problem. But we also have a decreasing. And what is the interval over which this function decreases? How would you describe that? It definitely starts at -4 on the x-axis, but how far to the right would you say this graph goes? To infinity. That's a hard thing for a lot of people to see. A lot of people look at the graph on number 2 and say, I don't buy it. It doesn't feel like it goes forever to the right. I struggled with that when I was learning about graphs. It does. It's hard to believe. But if you walked out like on that x-axis, if you took little steps and you walked 150,000 steps to the right and you look down, even though how far down the graph is below you would be incomprehensibly far, it's down there. That arrow and that curvature implies that the graph keeps going forever and ever and ever to the right. It just happens to be decreasing. So this ending interval is definitely positive infinity, right? And again, that's a conversation we had with a couple people yesterday, is that it's easy to want to put negative infinity there because the graph's going down. But the fact that the graph's going down doesn't affect the name of the interval. The interval is based on the x-axis, not what the graph is doing. You understand the expectation for this assignment? Again, please do not vandalize that piece of paper. We're going to use it for domains and ranges, probably, like I said, tomorrow. So now your objective for the day, I'll write this down so that we're perfectly clear, is to finish assignment number 30. That is on Delta Math. Also finish assignment number 31, also on Delta Math, and then assignment 32, which is the one we just started on our notebook. ¿Tienen preguntas? Do you have questions? All right, let's get her done. Short recording today.